Paula J from CQURE Academy, and welcome to another episode of CQURE Hacks Weekly. Today I'm with Mike. Hi.
Hi.
So Mike is our expert on database security and on infrastructure security, and today we've got a very nice subject, isn't it?
Yeah. Actually, today we will focus on network connectivity between client and the server machine. And Pablo will show you how to actually, what you can see in those packets. And
So I'll do the sniffing part and I'll do the bad part. Yes, so basically we're going to be checking out if the client is requesting the content of the database from the server, what kind of data do we have, and how we are able to eventually get it in a clear text.
yeah. And I will show you how to protect from that kind of attacks.
So what I will do within my demonstration, I will do the injection part. So during the sniffing, I'm going to be looking at the queries, and I'm going to replace a couple of parts of the query so that eventually we are making a change to the database.
Yeah. And later I will show you how to use certificates and encryption to prevent it. So,
Great. Bad one, good one, black clothes, white clothes. Let's dig in.
You should see my screen right now. And what we're going to do, well, first of all, I will just show you the environment. So this is the client simulating the application. And what I have over here, it's a regular query. I'm using the CQURE database, and I'm doing the select customer ID, company name, contact name, etc. And when I'm executing this query, you can see that what I'm getting actually is the regular table. Yeah, so there is actually some kind of information that I'm able to grab here. So I'm going to refresh that. So very regular query that applications do. Now I'm going to refresh the logins, where you are able to see that we have like regular logins here, so nothing really suspicious. And my job would be to sniff and spoof the query that is done by the application to the server, so that you are able to see that it actually runs in a clear text and we are able to see its content. Yes, so that's going to be a part of our demonstration right now. So right now I'm going to switch to another machine, which is a SQL server itself. And what we're going to do, we will open up a Wireshark over here. So let me do that very quickly. And we could just click on the icon. There is also an option. And after that, we're going to sniff the traffic, sniff these particular queries using the TDS traffic. So what I did over here, I put the filter TDS, and that means that we're going to be filtering the TDS related traffic. So now we have to just start the capturing and wait for the query to be done from the application to the server. Of course, it's not an application, it's just a regular management studio. But what I want to show you is that that particular traffic, these queries, they by default run in a clear text. So that's a bit of a problem, and I can tell you that from our experience as well, vast majority of SQL servers within the organizations, they are misconfigured like this. So these queries actually run in a clear text. And as you see, we had here select customer ID, company name, etc. Yeah, so that's something that we're able to sniff and eventually spoof in our demonstration. So I stopped the sniffing right now, and the next part that we're going to do, I'm going to move to the attack area, where I'm going to be configuring and running different types of scripts, where I'm going to be replacing this particular query, so the select customer ID, etc., by using Kali Linux. So over here, what you see is the SQL inject script, where I'm going to be specifying here select customer ID, company name. So that's the query that you already know. And I'm going to replace that by using the -i parameter, as you see, with the create login hacker with passwords, and then I'm specifying, of course, the password here. So of course it depends on who is performing right now the whole analysis, but eventually what is important is that we are able to see that technically in a clear text. So I started the whole attack right now, and as you see, I'm gonna execute the query so that we have something to replace. This time we can see that commands completed successfully. It's not really the table that we are getting from that. And here you are able to see that there is a SQL traffic discovered, and we found a string and we have replaced that. So eventually we have managed to execute our code, our query, on the SQL Server. And then when we're going to refresh the logins, and let's do that, so refresh, then you can see that I've got a CQURE login in this box, which has been actually created just by replacing the regular query that was running in the clear text. So this is pretty much what you can do with vast majority of SQL servers within the environment. And at the very end, now it's time to learn how you're able to make that particular queries and in general the traffic that is in between SQL Server and applications to not to be spoofable.
Hi. So Paula has just presented how it is easy to substitute some TDS packets content and how to attack the SQL Server. And now I will try to show how to protect. So I have two servers. One is the SQL Server, it's SQL01, and on this one I have running Wireshark. Let's verify that it's capturing the TDS packets right now. So I'm going to admin PC, and this is select hello CQURE hacks weekly. I'm executing this couple of times, actually 3. Let's see, go on the SQL Server 1, and now you can see that it is actually executed, and those are those packets with the data in it. So let's clear it again, continue without saving. Now I will go back to the admin PC, disconnect, and create another connection here, but this time I will in the options select encrypt connection, but without choosing trust, without unchecking the trust server certificate. So actually I will encrypt the connection, but no matter what is on the other side, I'm trusting the server certificate. So even if it's self-sign, and I'm executing again a couple of times of the query, going back to the SQL, and now you can see only the previous disconnection, no other connections to the TDS packets. And let's go and restart it, go back. So basically this is when you have a padlock here at the bottom in the SQL Server, and now it is protected, so no one can see it. But the man-in-the-middle attack is still possible, because I can just create a self-signed certificate and my SQL Server Management Studio will trust this certificate. So how about changing this connection? Okay, connection, connect, options, and do not trust server certificate. So I need to have a proper certificate. Connecting to SQL1, connect, and waiting for the error. It's still trying. Okay, the certificate chain was issued by an authority that is not trusted. So no matter if I type the fully qualified domain name, CQURE.lab, or not, it is trying to verify the certificate chain. It is self-signed, so it's impossible. Now let's go to the SQL01 and let's prepare for the encryption with using the certificate that is trusted. I can import or request a new certificate for the computer. I'm doing this from my local PKI, so I will see the template that was published on my certificate authority. Still waiting for it. Okay, this is computer, enroll, and in a couple of seconds I should see the brand new certificate that was issued for my SQL01 server. Okay, finished. So this is a SQL01 CQURE.lab. I cannot use in the subject alternative name, as you will see, short names right now, because subject alternative name only have the fully qualified domain name, and it's not enough to have the certificate. I need to configure it in SQL Server Configuration Manager. So I'm going to the SQL Server Network Configuration, right click on the protocols for the proper instance, and you can enforce encryption on the server side. But remember, if it's only enforced on one of the sides, it's still possible to perform the man-in-the-middle attack. So you should always enforce it here and also in the connection string from the client. On the certificate tab, now we can choose the SQL01. This is brand new certificate that we just created. Okay, the server need to be restarted. Okay, but before restarting it, remember one thing. The SQL server is running under the virtual account anti-service, and this is the name of the virtual account. So I'm copying it, and I need to grant privileges on this certificate to get to the private key. So manage private keys, add it, locations, SQL01, because this is local account. I'm pasting the name. Okay. We do not need to have a full control over it, just read. Okay. Now I can restart the service. So restart, waiting for it. Okay, let's go. So going to the admin PC, and again, let's check the connection options. Encrypt connection, trust server certificate. When using the short name SQL01, connect. The target principal name is incorrect, so I cannot do it. With the longer name, connect. And now it's encrypted. Oh, you see the padlock. It will not be visible. Oops, not this key. It will not be visible even if I hit F5 a couple of times. So let's go there. On SQL server, checking the Wireshark, nothing in here. Even if I go and modify the settings to the default ones, so disconnect, the default one for connecting is trust server certificate and do not encrypt. Login, connect. There is no padlock here. Can you see me? Executing this couple of times and going back to the SQL01. Nothing is here. No TDS packets in the Wireshark because it was enforced by the server configuration to encrypt everything. But remember, the best settings is to encrypt it on the client side and on the server side. Hope this will help you in protecting your connections to the SQL server. Thank you.